Hey, y'all, everybody. This is CoCoTECH number 5, and I still haven't got my powder down yet, but I'm working on it. So today we're talking about floppies and the grease weasel and the SCP. Hopefully, Paul Piscarelli will be able to join us shortly.
Yay!
But at the moment, I have Mikey Furman and David Ladd and Kevin Holloway as his David Ladd's engineer. And we're going to talk with, I don't know what. We're going to start with whatever. So, Mikey, it's all you. I think you're muted,
Oh yeah,
Mikey.
I did have an agenda, didn't I?
I hope you do.
Yeah, I was going to say his voice comes in a few seconds after the video.
All
Is he
right.
lagging or muted?
One moment.
Mikey's having some audio processing delay.
And I'm just here to teach David Ladd about floppies.
Hello?
I don't think it's my end because David Ladd looks like he's in sync.
Hi there.
Okay.
Hello.
Okay. So, how out of sync is this audio?
It's perfectly in sync to me now.
Yeah, it's good
here too.
Okay. Then this is what we're gonna have to go with.
That's what happens when you do it live, right, Mikey?
It was fine when we were just chatting. All right. So yeah, this is supposed to be a floppy talk, and some of you who may be watching may remember on the old show, which was CoCoTalk, we always joked about floppy talk, and I know that David and I always wanted to do it. We always wanted to geek out on all of our floppy knowledge. So I think that's what we're doing today. Right,
yes,
David?
It is.
Oh, indeed.
All right. So I did have an agenda. So mostly what we're going to be talking about today is about creating images of floppy disks. And these days we have tools that we can use which are inexpensive, that we can use those tools to make what are called flux images of a floppy disk. And it actually is a representation of the magnetic data that's recorded on the disk. When you use emulators like MAME or XROR, you're not usually using flux images. You're just using what are called sector images. That's like you write a file to the disk and you just read the data back, essentially. We're going deep. We're talking about, the North Pole and the South Pole of the magnetic particle. We're talking that level. We're not going to go quite that deep today, but so this is going to be pretty much practical. We're going to show in a few different configurations. I have a setup over here on the desk that I'm going to be showing you guys. I'm going to set it up and operate it. And I also have a stack of disks that I want to image, which are these ones here, Control-C. So, and then David has a few things he wants to show on his side as well. So, you have any opening comments, David?
I guess it would help if I was unmuted, right?
Oh yeah, yeah.
Really? So yeah, it's I'm waiting to go all crazy.
Okay, you don't want to add anything to my introduction?
No, I think you did a good enough job, sir.
All right. So, let's get into this. So, we're going to be using a device today. Let me change my view here. We're going to be using a device today that I have here, and this is a grease weasel, and it's basically a little development board with a processor on it, and the other side it has a floppy connector. And it has a USB port.
Which
over
developing
here.
board is that?
It's called
This
a
is
blue
a
pill.
this is a blue. This one is a little bit older, so it's a blue pill. It's a STM32F something something something.
Yeah, and then the
Okay.
one I'm holding up is called a greaseweasle F7, which is in the same form factor as the CryoFlux. So, but
ST Microelectronics is the manufacturer of the ARM-based ST micros.
Yep.
at least in the blue pill, yes, there's a couple other variant microcontrollers that's used in the F7, the V4. Now I think what's the V4.1?
Yep. The one that you gave me here is a little bit older. So
Yeah, that's the STM32F104, I think.
sounds vaguely familiar. I don't know where my loop is.
So is it a open source project to build one?
Yes, that one that Mikey's got, you can order your own PCBs, and then the biggest problem that you're going to have with that model is finding a blue pill that doesn't have a fake STM32 chip.
Could when you guys post a link of where to get the plans and stuff?
It's all on
at some point.
GitHub. Yeah, you can just go to greaseweasle on GitHub. You can look for that, I think.
Yeah, I'd post
All
a
right.
link, but unfortunately someone still hasn't given me permission to do so, so.
Well, I think that's with reason. Just kidding.
All
Just
right.
kidding.
I'll see
So
what I can do, Mr. Ladd.
have a greaseweasle. I'm gonna set this aside for a second. We also need a floppy drive, and I just happen to have a. You can see this is like still wrapped in the original cardboard with the locking plate. This is a brand new TEAC FD55B floppy drive. I have used it a few times, but I actually picked it up from the weird stuff warehouse from the surplus store, just like this. Saw a disk drive wrapped in cardboard, and I'm like, oh, I'm taking that home. So you need that. If you're doing disk imaging, you really want to have your best drive. And this is the absolute. The other ones I have, they're all used. So this is the newest one. So we'll take this guy out.
Is it better to use a drive native to the type of disk you're using? Like a 360K drive for a 360 disk, or will it work just as well if you use the high density drives for a lower density disk?
If you're just reading, you can use a high density drive.
Okay.
But you do have to be careful about the head span. It's the difference in between. So this is a 360K drive. Have another drive. This one's actually broken. This is a 1.2. You're not going to be able to really tell the difference in between them just by looking at them. This one I'm going to show something on it a little bit later. The difference in between them is the double density drives are normally they have 48 tracks per inch. So that means that every time the head moves, it moves a certain amount, and that amount turns out to be 48 tracks per inch. The high density drive for 5 1/4 is 96 tracks per inch. It's double. So this drive has a total of 40 tracks. This drive has a total of 80 tracks. And so if you want to use this 1.2 drive to read a 40 track double density disk, what you have to tell this drive to do in whatever software you're using for imaging is you'll have to tell it to step the head twice every time. because you're going to have tracks 0 to 79, but the ones in between don't have any data on them. So that's what you have to do to do it. And many people do not know that or think about it. So, any other comments, David?
Yeah, that's pretty much accurate. Other than that, I don't have anything to add. Other than when using a 40-track drive, the greaseweasle software defaults to 82 tracks. So you have to make sure that you, tell the greaseweasle software not to read past track 41.
Oh yeah,
So-
I did a cleaning cycle on this drive last night. I didn't realize that, and it went clunk, clunk, clunk. Oh crap, this is my new drive. But it looks like it survived.
So either way, you have to tell greaseweasle the physical parameters of your drive
Yes.
to work properly.
Yeah, I will show that. I will show that.
Okay. Yeah.
So let's move along. So to properly use the greaseweasle, you of course need a floppy cable. And the way that the greaseweasle is normally set up, it's set up for PC style, not Shugart style. So you notice this cable has the twist in it here, because this is a standard PC floppy cable. And I have one that has both kinds of connectors on it, so I can do 5.25 or 3.5, which I have the drive here. So I can use the same cable for both, but is it possible to run the greaseweasle in the Shugart style where you don't need to have the twist?
In the case of the greaseweasle that you have, Mike, which is the F1, drive select 0 and 1 are strapped together. So you don't even need a cable that has a twist. But now if you're using one of the newer greaseweasles that can use up to 3 Shugart drives or 2 PC drives, then yes, you would need an appropriate cable for the configuration that you're using.
Yep. Okay. This is just what I had handy that I can dedicate to this purpose. So I'm gonna go have one more thing I want to show, and that's I have a cleaning floppy, and it comes with some alcohol, which I'm not going to use this today. But if you're serious about making it preservation and making images of floppy disks, you're gonna want one of these. And this just has don't know what kind of material this is exactly. Guess it's some kind of plastic fibrous material. And basically with the alcohol, it just scrubs away all the dirt on the drive. Okay, and you need power supply as well. So I think David has almost exactly the same or very, very similar power supply to the one that I have. I just have a little power supply that has get this in the light, has this style of connector on it here, the Molex style connector. And I also have an adapter for this. I need to mark this so that it says top. So with the adapter, of course, here's the adapter. You can use the adapter to use it on with the Berg style connector to use it on the 3.5. So doing it this way with this external power supply is just handy. You don't have to have a computer or anything. You just plug it in. So those are all the pieces that you need: the drive, cable, greaseweasle, cleaning floppy, power supply, USB cable. I've got everything here. So I'm going to take this stuff away for a moment, and we're going to go down a slightly different path. So I happen, as I said multiple times, I happen to have this brand new drive that I'm using for imaging. So I know that nobody has used this. But if you have an old drive, you need to do some maintenance on it. And I have this other drive here which I can use to demonstrate this. So if you have an old drive, the maintenance that you need to do on it is, these are the heads here. I might be able to turn this. You can see a little down here. This drive is broken, so I can touch everything on it. Little white guy in there, that's the head of the drive. It's another one on the top. And you're gonna want to clean those manually before you do imaging. So you want to have at least, I happen to have 99% alcohol here. You can use about 90. I would not use 70. 70 has too much water. 90 should be okay.
Yeah, and the key is that you want isopropanol, not
Right.
methanol, because methanol can damage stuff. So got to be careful.
Isopropyl alcohol.
What, no Jack Daniels?
And have a little container of Q-tips here, and you'll just take. I'm not going to actually do this. You just put some alcohol in it, very gently, very gently. Lift up the head, and wipe. And that's the maintenance that you need to do for the heads. Of course, the head moves back and forth with the stepper motor. So I can hold this up a little bit more. You can see the head rides on these rails here. This one here, and there's another rail down here. You may want to clean those, and you may want to put this particular drive. They're on these rails, so you use something like a light machine oil. You wouldn't use grease on this. A light machine oil of some kind would be the right kind of lubricant for these rails.
Like a sewing machine oil?
Yes,
like a sewing machine
that's what
oil
I
or
was
something
going to
like
say.
that, right?
Sewing machine oil is what.
Right. And of course, take it apart, clean everything. And this drive is I broke it by turning this connector around because I was futzing around. This was a freebie. This particular drive here was free from the VCF West pile, so I didn't mind breaking it. Plus, it's a 1.2, 1.2, and I have a bunch in the box. So that's the maintenance that you need to do on any drive that you want to use for imaging. You want to make sure the heads are clean. You want to make sure that if there's a slider bar, you want to make sure it's lubricated. This particular, I don't have a 3.5 handy. If it has a worm screw drive, you do want to use a little bit of grease on the worm screw drive. Yes, Mark.
I would suggest not remove the rails.
Oh no! Don't take anything out.
Because you said take it all apart and clean it. I would not
Oh
remove the rails because
no. I should be more. Thank you. I should be more specific. Should just like take the circuit board off, and don't go any farther than that. Don't take it apart any further. You can take the circuit board off. You can just disconnect like these connectors here. Take the circuit board off. Get inside with a Q-tip or something. Like this has all kinds of crap inside it. Just clean all this stuff out. Yeah, thanks. See.
Yeah, because
here's what the Q-tip looks like. I just wiped inside of this thing.
Yeah.
See how it looks ugly. So this is going straight in the trash.
Because that steel band that goes from the stepper motor to the head.
Oh yeah.
You get a kink.
Thank you for clarifying that.
You can throw that. Yeah, you might as well just throw it away if you get a kink in that thing.
Now there's one thing I would like to add, Mike, is that there's two parts that I wouldn't remove, which would be the track 0 sensor.
Yeah.
PCB. I wouldn't unscrew that. And I also would not unscrew the index pulse sensor either.
Right. Yeah. Index pulse sensor is this one right here.
So really you can take the board off to clean underneath it, but don't really remove anything else.
Thank you, Mark. Yes.
So we have a question from L. Curtis Boyle. Says WD-40 is not recommended.
They think it'd be a little too light.
I know it's not really good lubricant. It's more like break
The
things
degreaser.
free.
Yeah.
Yeah, degreaser.
Yeah.
Yeah, I plus WD-40 on certain plastics can be bad. And some of the floppy drives have quite a few
Weird plastics.
plastic bits. So yeah, I would refrain from WD-40. Again, lubricants would be the light sewing machine oil.
How about like gun oil? Like for
That
lubricating
would
a
probably be okay. Another lubricant that leaves a film, which unfortunately would probably be a little bit too expensive, would be Deoxit, because it leaves a film behind.
yeah.
But
The only drawback of lubricating that is it then starts attracting dirt and becomes
Yep.
sticky. So that means you'll have to do maintenance more often.
Yep. But it needs to have a little bit.
No.
If it's an old drive, if it's an old drive that you haven't used in a long time, you should at least put a tiny, tiny, tiny bit of oil on it.
Yeah, sometimes those rails are so gummed up
Right.
sticky you can't even move the head.
Todd Wallace asked, is it possible to hook it directly up to a CoCo drive? I know that the CoCo drives are like the original single-sided PC drives.
Yeah, but you'd be limited to the capabilities of
Single-sided.
the drive. Yeah.
Right.
no,
Especially the original ones would be 35 track.
Yeah, I don't know about those, but the later ones, like the full height later ones, are just standard drives.
yeah, the old full height ones would still be. Most of them were 35 track. Some of the later ones could do 40, but they were single sided.
Right.
The FD 502 floppy drives were the first ones that were sold that were for the CoCo 3, specifically for use on the CoCo 3 with OS 9 level 2,
Mhm.
because they were double sided.
And double-sided drives were cheap and easy to get a hold of at the time.
Yeah,
Yes.
finally by that point.
But if you're going to do imaging and you already have a drive that, yes, then you could use the CoCo's floppy drives, because all they are is the same Shugart connector. So
Yep.
Mhm.
A lot of people don't remember the original IBM PC shipped with single-sided drives, and then pretty quickly they made them double-sided.
Yep. All right. So let's get moving along here so we can actually do something. So got the drive back here and plug the cable in. This one does have the separator, the key. So this cable only goes on here one way. And I've got my power connector. David, how's the Molex connector on your power supply? The one that I have, it's very, 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 very hard to make sure that this thing goes in the right way. Because the corners are not very, it's black, so the corners are not very pronounced. This looks like it's the correct way here.
mine, the power supply I got came with a IDE hard drive transfer kit.
Yeah, that's where this one came from too.
And yeah, some of those are kind of hard to tell, but yeah, you definitely need to make sure that you get it in the right way. Otherwise, you let that what they call the magic smoke out.
Yes. All right. So drive is connected to the power supply.
I guess if you're that much of a gorilla, you get it plugged in upside down.
I actually somehow was able to plug one in upside down into a hard drive.
Ooh.
Okay, and the drive is upside down, so let's fix this. Greaseweasle is attached to the end of the cable here. And all I need to do with this is plug in the USB cable, and then we can move over to the computer and start doing a couple things over there.
Ooh.
So I got to push a button here. Right. So first thing I'm going to do here is make sure that, by the way, when you install the greaseweasle software, just run it with GW. First thing I'm going to do is run the info command, and it will tell me that I have greaseweasle F1. It'll tell me the firmware version, and so it actually does detect it. So, all right. So I actually do want to do imaging. So what is it? Sils equals 40, I think. I'm going to do a cleaning cycle. So I'm going to do a dry cleaning cycle. So I just put this cleaning disk in here. And close it up, and we're going to watch this thing do a cleaning cycle. It's going to do it 3 times in a pattern, which is going to remove the junk from the head, if there is any. Again, this is a almost brand new drive, so
Now, wouldn't it
there's
be
not gonna
neat
be
if it
that
picked up
much.
an image off of that?
What's that?
Wouldn't it be neat if it picked up an image off of that?
An image of what? An image of fibrous stuff?
You never know what might be on the floppy.
So there we go. Did the cleaning cycle. Seek 0 motor on. I'm going to tell it to pull the head back to track 0. There we go. All right, I'm confident that this is clean enough that I'm going to just go for it here. We're going to take an image of a real floppy disk. So I have this stack of disks here, which is Control-C for Flex. And I have 2 different versions. I have this version 1.54. And I have this, whoops, there's an extra disk here. We already have an image of this disk. This is the one you see in all my videos. This color computer flex disk. We don't need to image that one. So the sector images of these disks. So I can find a copy of this Control-C for Flex. It's out there, but I want to preserve. You know, these disks came to me. Somebody gave me a collection. This guy Delbert Franz, I think, was a friend of my friend's dad, so family friend, and I think he was a professor at a university or something like that. So we're going to image these. So I'm going to take the first disk here. And before I put it in, I am going to take a look at the disk a little bit. See if I can turn this quickly so you can see. And I'm just going to turn, it's not really in focus. That's a little better. Just going to turn this. You can see in the reflection, I have the reflection on the camera a little bit. Don't see any junk, any
I just
scoring.
see a bunch of zeros and ones.
Yeah. You want to actually, if you want to get a good image, okay, you can see a little bit of scoring actually. Can you guys see that? If I turn this back and forth a little bit, you can see there's a little bit of scoring on this disk. Well, it's not that bad.
Well, if it gets to looking like a record, you're in trouble.
Yeah. So that's this side of the disk. The disk is turning freely in here. It's not stuck. It doesn't seem like, I get the right angle again. It doesn't seem like there's any junk. So you want to inspect the disk to make sure that it's in good condition. Now, David can talk a lot more about restoring disks that are not in good condition. I have never done that myself. So, so David, let me get this started. I'll start making start imaging these disks. And while that's going on, maybe you could talk a little bit about what kind of restoration you need to do. You can do to floppy disks, like you were talking earlier about L. Curtis Boyle's source code disk. So let me get this started, and we can talk about that while I'm running these disks through. Now, this particular drive, since it's a little bit newer, it actually when you close the drive, it actually spins the disk. So you don't want to just take this lever and just slam it down. You want to actually do it very gently, because what you want to have happen is, where's my junky drive so I can tell you and show you here. So when you close the lever, you can see this hub moves up. It's not going to go down because there's no well, I can push it down manually. Where's that hub? When you put the disk in, this hub here, this white thing, goes into the top of the disk, and it clamps down on the bottom part. And so you want to close the door gently, because you want to make sure that this locks in on the center of the disk. Right, we're talking about the hub going into the center of the disk. So you don't just jam the lever down on this kind of drive.
Well, as you can see, there's a lot of play of the media within the jacket, and they don't always line up 100%. So you want to let that cone grab it and kind of center it without punching a hole.
So I'm going to gently push this down, and it's starting to spin, and that should be good. That should be good enough. Alrighty, back to the computer. And while these, I'm going to do one, and then after the first one, David, you can talk a little bit. So GW read. Now, I'm going to say something. I don't know exactly. I think these are single-sided disks. Actually, it actually says right on it. It says single-sided, single density. So I'm going to probably image the first disk twice, because I think I'm going to image it, and then we're going to look at it to make sure. So tracks, any equal sign C. Is it like this? I don't remember the syntax. We'll ask it. I always forget this. Tracks equals, where is it? Okay, tracks and a track spec. All right, that's fine. So I'm going to start with, we're only reading single-sided. So we're only reading head 0. And cylinders equals 0 to, I'm going to go to 39 on this one. I don't know exactly how many tracks are on this disk. And I'm just going to call this test for the moment. And then we'll take a quick look at it and see what it looks like. And then we'll do a real read on the second time. So I'm going to let this go.
Okay. A little footnote. Drives number the tracks starting at 0 and then counting upwards. So track 39 is the 40th track.
Yes. It's going through each track, and it looks like we're still getting data. I'm expecting after track 34, we may not get any more data. We should be able to see that. No, it looks like we're still getting data. All right. So we're going to actually use one of the tools, and we're going to take a look at this.
Ooh, and what is this tool that you speak of, sir?
This tool is HXC floppy emulator software. You guys see that?
Indeed I do, sir.
All right. So this software has been around quite a long time. In fact, it says copyright starting 2006. So originally, this software was supposed to be used for a piece of hardware called the HXC floppy emulator, but I don't think you can get that hardware anymore, right?
No, you still can. It's basically their version of a CoCoTECH. Or I guess I should say technically a CoCoTECH is a version of their drives. but
Okay, so you can still get it, but this software works with many different formats. So here's the image that we created. And I'm going to just open this up. And then I'm going to go to the track analyzer. Let me move this 1 moment. Okay, that's a little bit better. So I'm on, there's only one side, and I'm on track 0. Now this is a flex disk, so I want to look at sector 3. Where are you? Sector 3. And it's probably a little bit fuzzy in the zoom. But I can clearly see that this is intro C. And the directory starts on track 5, yeah. icc.command, c1.command. So this looks like C compiler stuff that I have on this disk. And I can actually, what I actually showing is you can actually look at the data on the disk. There's something else you can do. You can actually view in this format what the disk looks like, and you can cruise through the sectors here too. This is the view mode. I don't think you can, yeah, you can see that I have view mode set for 48 tracks per inch. So I skipped over something. I'm going to go back.
So the tracks are interleaved. That's why they're set to skip getting to track 3.
The tracks are not interleaved. The sectors are interleaved.
Sectors are, sorry, sectors are interleaved. Okay.
Yeah. So that's why we have 6, 1, 9, 4, 7, 2, 10, 5, 8, and 3.
Okay.
So I don't know what it starts with 6. I don't know what the interleave is. Go 1, 2, 3, 4. It looks like it's 3. I don't know if it's 3 or 4, but something like that. I think it's supposed to be 3. I skipped over something. I want to look at this track 3 and look at something. All right. So I don't think you guys can see this. I'm looking at the screen here, and I happen to understand the flex disk format very well. So I can look at the screen and I can tell you this is a 40 track disk. No, it's only 35. Because it says it's 22 hex. Then it says 0A. So it's 10 sectors. So, okay, so this is 35 track disk. So I'm going to go to track 34. We still have some data here. If I go to track 35, there's still some stuff here. That's weird. Okay. I think this is actually a 40 track disk, even though it says it isn't. Well, could somebody help me? What would the 40 decimal be in hex? 32 plus 8, right?
Is it 20? Is it 28?
yes, it's
Yeah.
28.
Huh. Well, that's interesting. I'm not sure why this disk here, the data, I don't see 28. I see 220A, which would be 34. This is, see, you get these kinds of mysteries when when you do disk imaging. So the file system on this disk says that it has 35 tracks, 0 to 34. But we did the image, I did the image for all 40 tracks. And there's some stuff out here on this disk. I don't know what this stuff.
Could there have been some stuff, say, left over from a previous life of the disk? That was at
It's
40 tracks
possible.
and then later it just got used as a 35 track? Or does Frank Hogg have some secret stuff out there?
This is not Frank Hogg. This is again. Oh, I don't have the camera. This is intro. This is intro C.
Oh, okay. I thought you were doing one of your flex disks.
Oh no, it is a flex disk. It's a flex format disk.
Oh, okay.
It's
But that's commercial software.
Flex. Yeah, this is commercial software. Flex 09 format.
Well, you wouldn't have think they would be reusing disks.
Yeah, so this sector looks like some C source code. So this is why you do a test run and you take a look at it and you see what's going on with the disk. There is clearly some data out here. Can I see anything? Track 10. No. See so according to Flex, the end of the disk is right here. This sector that I'm on right now is track 34, sector 10. This is the end of the disk, supposedly according to Flex. And the Flex file, the data here is all 0 on this sector. So according to Flex, this is the end of the disk. But there's actually something. Whoops, where'd it go? There's actually data out here. 35, there's data, 36, 37, 38, 39, 40.
Could the
I wonder if I
program,
should.
could the program that's on the disk, when it runs, modify your disk parameters to get at those extra tracks?
In Flex, nobody really keeps track. Whatever. So the way that it's supposed to work is that there's supposed to be a parameter. That's not true. There is a last track and sector parameter. That's the one that I read off to you. It said 220A for 35 tracks.
Well, that
but
may be
I
a
guess you
mystery
could. I
for
guess you
another
could
day.
go poking in and change it if you wanted.
Yeah, that
So-
might be a mystery for another day.
Yep. I wonder if I should do a couple more tracks just for fun. And I wonder if I should do double-sided just for fun too. What do you guys think?
Yeah, to see if maybe anything's out there on
Sure, why not?
41 or 42.
Yeah. All right. I don't have I need to set up
So just for the audience, some drives, you can get an extra couple of tracks out of them before the head bangs against the hub. Not recommended, but sometimes you can squeeze an extra track or two out of them.
Yeah, on
I'm
three
just
and a
gonna-
half inch drives, I routinely got 82.
yeah.
Yeah.
There was a couple of drives I had that I could actually get up to 84, but that was a rarity.
Those TEAC drives, with those 35 track TEAC drives, weren't happy with it.
How far do you think I should go? I put 2 tracks. Think I should do 1 or 2?
I probably, for safety, wouldn't go anything more than 41, which of course with the greaseweasle software would be 40.
Right. Okay, so just 1 additional 39 and 40. Just 1 additional track, you think?
Yeah, because most of the 5 1/4s I used that was 360K, I rarely saw one that could go past an extra track.
Yeah.
And usually if
okay.
you went to 42, you definitely get a head bang, which
Yeah.
that can throw a drive out of alignment if you do that.
Yeah, which I already did to this
Yeah.
poor drive the other day. So let's do this read and see what happens. We added 1 additional track.
And roll
And
the dice.
we're doing double-sided this time too. So just to take a look. And it's taking longer because it's doing head 0, head 1, head 0, head 1.
I'm assuming your reading is SCP.
Yes. That's the native format for a greaseweasle.
Which also happens to be the format that was created by the guy that made the Supercard Pro.
Right.
which I got to see one of those at CoCoFest.
Because you said that Paul has one, right?
I think Paul has one. The gentleman by the name of AJ from Forgotten Machines showed up at CoCoFest, and he brought his SCP-2 with him.
All right, so we just did test 2. And let's load this one up and see what we get. Okay, track analyzer. So, now I have 2 sides. So here's what the other side looks like. It is completely blank.
Yeah, I'd be surprised if there was anything on that.
You know, a view I like using myself, Mike, is the
We can switch to this
disk
view.
so that way you can see
This view?
Yep. That's
Yeah.
actually how I more quickly see if a disk may have damage to it, because usually a sector, instead of it being green, will be either orange or red.
Right. So you can see that this extra track here doesn't seem to have anything on it. The extra track that we added. And the other side that we added doesn't have anything on it.
So that red line at the very inside is that that extra track?
Yeah, the red line that's inside here, this is the extra track. This should be track the track number is not quite right.
So it's not able to read any sector information, so it's treating as a bad read.
Yeah, right.
Yeah, usually if there's no actual valid format, it'll be snow, or what is it they call that? Galactic noise.
Yeah. So here's track 39, and we added track 40. And there's nothing there. So to properly image this particular disk, it's single-sided and 40 tracks. Now I know that. So I'm going to do all of the rest of the imaging of all of these disks exactly the same. Would you, I just want to see, would you agree with that, David? Just do all of these 6 disks exactly the same as I just did this one.
Sometimes I will read the whole disk as a full image, just to see
yeah,
if there might be any variances in the disk, because especially if the disks, the labels have come off, or you've got a box of floppies that someone gave you to say, hey, could you image these, and you have no idea what's on them.
Because you're making the assumption that all the disks are now going to be the same as the first one you did.
Yeah.
And
then this is going to take a while to do.
You know what they say about assume.
That's why I always assume to grab it all and then look and then re-image it with the specific format I need.
Because somebody can sneak something in on you.
Well, if it was someone like me, I've been known to hide things in sectors.
Okay, so this is going to be the final read for this particular disk. And I gave it some name that makes sense. Control C 1154 disk1.scp. And we'll just read it one more time. I'm only reading 40 tracks. Okay, so I'm going to work through this stack of disks. And David, while I'm doing that, I asked you to talk about what to do when you have disks that are stuck or have crud on them, or
moldy,
other things like moldy or other things like that.
Certainly. So that when Mikey was going through showing where he was looking at the reflection of the media, and he was making sure the disk was turning okay and seeing if there was any scratches or stuff like that. Usually if there's scratches, that's bad. You really have to be careful using disks that have scratches, because that means that media could still come off and collect on your head. But if you see weird discolorations on the floppy disk, bumps on the floppy disk, like something's gotten on it, then the media needs to be cleaned. There's been some YouTube channels that I've seen where people have used isopropyl alcohol to clean the disks. Don't do that, because unfortunately I recorded a video and I never made it to my YouTube channel, but alcohol breaks down the bonding agent that binds the metal oxide that's on the floppy disk to the mylar disk. So when you wipe over the media, you're actually removing the metal oxide off the disk.
Taking those magnetic fields right off.
Oh yeah. So you do not want to use alcohol. So one of the things that I will do on a 5 1/4 is on the sleeve, I'll open one of the sides. I will remove the media, and then I will use, you do not want to use boiling water, but you do want to use hotter than lukewarm. You want something where it's warm, and then you put it in the water, preferably distilled water, because you don't want minerals getting on the disk. And then you just let it soak, and you just carefully work the disk. And then with it being warm, if the stuff that's on it was like pop or some other stuff that someone accidentally got on it because they were drinking a soda nearby, that warm water will help dissolve it and remove it. Then one of the things I use after that is those, you can get them at like Walmart or some other store, but in the beauty section there's those facial wipes that you can get. They're come in a tube about yay long, and
the round kind of clothy.
Yeah, one side is a little abrasive, the other side is just completely flat. But it's kind of like made out of the same stuff cotton swabs are.
Is it a makeup applier?
No, it's remover. It's to clean.
For removing, yeah.
So then what I'll do is I'll use those to dry the disk.
I think I've seen those around the house somewhere.
But yeah, then I'll use
Probably.
those to dry the disk, and then I will examine the disk to see if it's clean. If it's clean at that point, I will then use a brand new floppy disk. I will then open it up, remove the media from the new disk, and then stick the disk that we're trying to recover data from into the sleeve that the other disk came out of, and then I'll use that to be the host carrier to put into the floppy drive.
Because the original sleeve is probably contaminated as well.
Yes.
Yeah.
And you don't want to recontaminate a disk that you just cleaned. So, and then there's another thing that I'll do, which some people will say I shouldn't do it, or other things, is after I dry the disk, sometimes I will use a little bit of Deoxit on the cleaning pad to wipe down the disk, to just give it a little bit of a coating, so that way the disk will glide a little bit easier over the heads.
A little bit of lubrication.
Yes. And I have not had any issues with the metal oxide coming off on the wipes.
Does
But
it dirty
again,
the head?
right. It's just, you know, but like
does
any
it
of
dirty
this
the
stuff,
head?
old technology, you just kind of have to wing it when trying to recover stuff. And Curtis had brought a floppy that had some source code from, I don't remember who it was, but he'd gotten a disk from, and there was something on the media. Well, I didn't have a chance to clean it at CoCoFest, but I had to keep cleaning my floppy drive while I was trying to recover the disk. I finally got enough of it that I was able to get the data off of it. But when I got home, yeah, I soaked it really good in some hot water to get the crap that was on the disk off. And then after that, the disk read like there wasn't any problems. But yeah, it's you just have to do what you got to do to try to recover the data.
Yep. So while David was talking, thank you, David. Whoops. I discovered that this second disk, let's go back to this view here. I discovered this second disk only has 35 tracks, which is what I was expecting. So I did 48 tracks, but the last few tracks are red.
So yeah, so you can see the red in the middle there.
Yeah.
Why also on that disk is on the last view?
Mm-hmm.
Between two of the sectors there's extra space.
Ah.
How's that?
That's something interesting.
That's called sector gap.
Yeah, that's not the sector gap actually.
Kind of extra.
So as the disk
wide there,
as the disk goes around, every disk has an index hole, and there's an index sensor that detects. Here I've already imaged this disk, so I can literally show you. If I switch
the first
this,
disk
and
you didn't do that.
It did. It should have.
Well, it didn't have one that big. It had the little ones between the sectors, but there's.
Okay, so if I gently turn this disk around, eventually, there we go. See that hole there? That's the index hole. So there's an LED and a photodiode, which it uses to detect this index hole. And that index pulse from the sensor, it gets sent back to the controller. And the controller gets the index pulse. And when it does get the index pulse, that's when the controller starts writing the data. When it sees that index pulse.
Okay, I just didn't notice the first disk you did having a gap like that.
Let me finish the explanation. I haven't quite gotten there yet. So the controller starts, when it sees the index pulse, it starts writing the data. And meanwhile, the disk is going around and around and around and around and around. It keeps going around. The reason why you see this gap here is because the controller wrote all of the data for the track, all 10 sectors, and it had no more data. There's no data written here because these are the ends of the track.
So it has some spare time, you're saying?
It has spare time, because if you had too much time, then you'd be overwriting the data you already you got past the index pulse, and you're overwriting the data. Okay. So the other disk should have a gap as well. The gap might be a different size, and it might be a different size because I have no idea how these disks were duplicated.
I do.
Okay.
It has to do with the speed of the drive. If the
yes,
drive
I was just going to say that if you write the same data on a few different drives that are slightly different speed, this gap here is going to be a different size. So if I go back to the other image, the difference is going to be that the gap is a different size. Yeah, it's pretty close, but it's actually a different size. So that's what this particular gap is. There's just no data there because the controller wrote out the controllers generally unless you're modifying a single sector, they're going to write out a whole track at a time pretty much
So we got
for
finished
copying.
before the speed got back around, before they just came
Before
back
we got
to
back
0.
around to the index hall, yes. So
Yes.
Which is a
will
desirable
always see a
thing.
little bit of gap. You
Right.
should,
Okay.
if you don't, then that was actually a good question. So let's see here.
Now, I could
Um,
add extra information to that if you like.
Oh, absolutely. I'm
Go
going to
for it.
go back to if I get the correct view, should be this one. I'm going to go back to imaging these disks. So you guys can talk for a while while I try to finish this up, because I think
So,
we have time.
so like if you look at my screen over here, I've got what would be a blank OS9 floppy disk on a 3.5-inch drive for Coco, because if you
So it's
look, there's
almost a whole sector's worth of space free.
almost. Now, as Mikey was discussing, these areas is, if you look at either the FM or the MFM encoding, there's this area actually is data, but it's not data that's read as a sector. It's data that's written as a part of the track. And its value, I think, is 4E hex. And this data is usually roughly 84 bytes long at the start of a track. And then in between each sector, there's also a small gap. If you look here, there's a small gap. And that's also filled with that same gap filler. But that's something that normally you would never see as a program or an operating system, because that's a gap.
It's just that's between the drive and the controller.
Right. Now, that area is where some people that added copy protection later would hide data. As most of the floppy controllers, like the one that we have on the CoCo, can do a track read. So you can actually read the entire track in one pass instead of asking for sectors. And then you can check for data that's been hidden in the track data. But that takes, a programmer like, Steve Bjork, or, some other programmer that's trying to keep their game safe from pirates that would be ill-willed wanting to copy the game.
And Curtis is suggesting in the chat that that's the place where the 20th sector could be put, like if you format it with more sectors.
That is also correct. OS9 and the technical reference manual actually lists how the track is laid out. At the gap that's at the start, the gap between the sectors. There's even the sector itself even has a header and footer that you don't really fully see here, and you can reduce the header size of this the header that comes before the sector, which is how the controller knows where the sector is on the disk. You can shrink all of this information down.
And the trade-off of that would be, say, reliability, maybe?
Strangely enough, a lot of people would say that would be unreliable, but Curtis, Bill Noble, me, I used that method in the 80s and never had any problems. And that's, the only problem that you might find would be as if you was already using, marginal floppy disks to start with.
So I'm thinking the designers at like Shugart or something wanted to build in some tolerance against drives that may be fluctuating, or controllers that couldn't quite keep up, or that sort of thing.
That's always possible. But then again, everybody sets down standards.
Everybody has their own.
And then and of course, you know, then there's always the people that find, well, if we change this, we can squeeze just a little bit more space out of the discs. And that's how you get 20 sectors per track with that special format utility under OS 9.
Refresh my memory. What was the standard sectors per track?
18.
18. Okay.
And if you didn't do any funky stuff, but just reducing the gap at the start of the track and the gap between the sectors, you can get it to 19, just barely.
Mm-hmm.
But yeah, to get that 20th sector, you start having to reduce the gap information in the sector headers themselves too. You really start playing with the
It's a little tight.
yes.
Okay.
But one of the things I use the greaseweasle for is I'll get an image like what you see here. I'll get an image that works. I'll write an image to a floppy disk, then I'll read it to make sure it wrote correctly. And like this one that you're seeing here, this is an image that was written to a real floppy disk, then was read back. And as you can see, it's all green. There's no red. There's no orange. And if you was to write to a floppy disk that's supposedly new, or you reused an old floppy disk, you know, you're going through trying to clean up disks.
Mm-hmm.
If you see any large amounts of orange or red, when you read back the disk to make sure it checked okay, yeah, you probably don't want to use that floppy disk.
Because it's orange means it struggled getting the
Yes.
data.
Yeah, it's but yeah, there's the greaseweasle comes in very handy. It's what a lot of people would call, it's a forensic analysis tool, just because the fact that you can analyze the media and see if you can recover the data.
So,
which Curtis was a very willing participant in that project.
so to go down a rabbit hole that doesn't really apply to the hobbyist market, does the greaseweasle handle hard sectored discs?
I have no idea.
Okay.
Since really it's meant for the Shugart style interface.
Yeah, I don't remember. I actually don't remember, but I have a hard sector disk here, I think. Let me see.
Yeah, but do you have the drive that goes with that specific hard sector disk?
Yeah, because the index hole's in a different place.
I would think it would just read the whole flux thing, and then it would do some basic like FFT, fast Fourier transformation on the image and try to figure out where the sector should be without even knowing where the other index holes are.
Oh, I thought I had it, but I don't. I'm looking in my box.
Well, I wonder if it would just, if you could, well,
No, this is
that's
soft
going,
sector. Or
yeah, that's
single.
going down a that's going down a rabbit hole we don't need to go down, I suppose.
I do have a bunch of 10 sectored hard sectored discs. I actually have, I was gifted a North Star Horizon system with 2 SA 400 drives in it.
Do they have 2 index holes or just one?
It only has 1 index hole, but it has definitely hard sectored marks on all the floppies. So it has basically the start index hole, and then it has one every sector.
Okay, so that's what I was thinking. There's a separate indicator of where sector 0 is.
Nope, same hole. If you look at it, you'll notice that pretty much all of the disk is all divided into basically 10 sections. There's a hole for each section, and then there's an extra hole between 2 of them where the track starts. So I don't know. It must do with the timing. It must know that when it sees a double bip, that knows that's where the track begins.
Okay, so the greaseweasle would need to be programmed to take that into account.
I
Yeah,
think it is possible.
Yeah.
But I don't know if you need a specific version of it or what.
Yeah, it doesn't apply to what we're doing today, though.
Yeah, I was
Right.
going to say when
I have some of those discs somewhere, some hard sector discs too. But I don't have them here. Yes, this is 160 disc 2, right? Yeah.
yeah,
Buck Owens wants to know what's the difference between the grease weasel and the cryoflux.
Oh,
grease weasel's cheaper.
hey
and
David,
available.
what happened here? Can you see? It says fatal error.
Uh-oh. Hold on. Let me see. Get back to the Zoom screen. Now, if I was using the right trackball,
Data in range must be 0 to 256. Wow.
where, what?
I started reading, and then, whoops. Oh, one moment. You can't see that now.
Must be a super wide byte.
Oh, you found the copy protection.
Can you see that a little better now? I made it bigger.
Oh, that's interesting. Byte must be in the range of 0 to 256.
Yeah. Let's do this. View seek 0. Let's go back to check 0. Okay. And let's just do this again and see what happens.
I noticed on YouTube the image is cut off just a slight bit on the bottom.
Well, it's working now. I've had that happen a few times where it has a fatal error, and then I should probably, when I'm not doing something that I actually want to archive, if I ever hit that in something that doesn't matter, like I don't really want to touch this disk again after I'm done with this. But
Yeah, if
I hit that again, I should probably report the issue.
yeah,
so that
I've
we
not
can
hit
figure out-
that problem, but I just recently, of course, I was up late last night trying to get stuff set up, but like the grease weasel that you showed, which is the model F1, since that's a blue pill micro development board, I went through and updated all of my grease weasels that use those with the most current bootloader and firmware.
Mine's latest firmware, which is 1.4, right?
Yes, but
Uh,
depending on the original firmware that was written, the bootloader is normally a part of it, unless you're updating via the USB. Then the bootloader never gets updated. And sometimes, if there's been enough version differences, I'll manually do a full chip erase and then update the bootloader as well. But that requires the STM link adapter to program the chip directly.
They aren't that expensive though.
No, not the knockoff ones. They're like,
Not
I think
even
most of the ones I got were like a couple bucks.
I
But
bought
you have
the
to be
official one through
careful because I
DigiKey.
got like 5 of them that were fakes.
I bought original one from DigiKey for $22.50.
Oh yeah, that's the full one. Yeah,
Trust me, less than 25 bucks is cheap. You go
well,
back 20 years and some of these programmers were literally hundreds of dollars, if not 1,000. Dragon Bites wants to know, is the Grease Weasel software command line only, or is there a GUI version?
It's command line.
We'll get into that in a minute. There are GUI tools you can use. In fact, David, maybe I can let you. I'm almost done. This is the 6th disk. I just wanted to show one thing here. You can clearly see on this command line how many flux transitions is 136,000, 131,000, 105,000. Then all of a sudden it changes to 99, 97. So this is track 34, 35. So this is a 35 track disc. I can literally see that on the screen right here.
Yeah, and someone would ask, well, what's those flux transitions then? And I'm like, it's
No,
called
we're not going
white
to go. We're not
noise.
going to get into that today. If anybody really wants to know, I can recommend a document to read. It's from Shugart.
Yeah, well, it
And
also
some of
applies
it
to
goes
audio
over
tapes
my head. So
Let's
Well,
put it in the notes.
it also applies to audio tapes that have never been used too. When you press play and you hear
Yeah.
that nice
Noise.
nice
Yes.
noise. It's just random flux.
David, do you have Flux Engine, or should I demo that?
I only use the command line, and that because I prefer
Okay.
using. And so
Then-
if you've got a GUI and you want to demo it,
I do
go right
have Flux.
ahead.
I do have Flux Engine GUI. I can show. So what?
A lot of people like a
image up?
GUI, but when it comes to this, I personally prefer having more control over what's going on. So that's why I like using the command line. Because also, like what you pointed out, you can see what's coming across the flux transitions and how long it's taking.
Besides GUI, get your hands all sticky and
How about if I image a disk using that's not really that important? What do you guys think about this one?
Oh, you're looking to get Curtis all worked up, aren't you?
I can find something. Else. How about the Pegasus and the Phantomators?
Oh, actually, you know what would be good to show is if you have any of the disks that are known to have copy protection on. If you've got any of the original floppy disks, like the original Radio Shack Seamus.
You mean this one?
Yeah.
Okay.
I believe it was Sector 9, if I remember.
This is version 1. Is it in version 1.0.0?
I think so. I don't remember.
Okay.
Because you'll know, because if you had a real Coco and you tried to back it up, you'd get the dun 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 dun, because it couldn't back it
Got
up.
a bad sector.
Then let's just do a cleaning cycle. I'm gonna let it.
You can always use any AOL floppies. Those are
Not with that drive he's using, you wouldn't.
I have to use this drive.
Oh, that must be a new command. I didn't know that they added the clean function. Geez, I'm behind.
You see the head step there? It steps back and forth.
Yeah.
Yeah. Okay. Disk inspection. Oh, that looks super clean. It's turning easy. There are no scratches on this.
Hey,
disk.
David Ladd, I had some box of floppies. I got these like in a really nice flip folder from a local stationery store that were branded. There was like 4 boxes brand new. I went through and found out that probably a quarter of them, even though they've never been opened, they had like mold in them. I mean, you'd go through and you'd see the floppy. It's like, oh, there's mold on the disc.
Yeah, that means they were not kept in a place that was really that great.
Yeah, it's weird because they were still sealed in the original. They had an out wrap seal. But anyway, the disc boxes still are nice, and some of them were good. But
I wonder if when they manufactured them, they weren't in a ideal condition either.
That's what I figured.
Because they didn't expect them to sit around for 30 years, right?
Okay, I'm ready. I'm ready to go with this unplanned demo. So this is the Flux Engine software, and the Flux Engine software is actually a different imaging device, which I don't have a Flux Engine. But the Flux Engine software does work just fine with greaseweasle. So I'm running this on the Mac. Linux is going to look almost the fit and finish is going to be a little bit different widgets and stuff, but it's still pretty much the same. So I just select greaseweasle drive 0. And this is not a high density disk. It is 5 1/4, 40 track sort of. Format. So this is going to get messed up. So it doesn't really have, I would have to add, I don't think it really has color computer.
Wouldn't CoCo just be like IBM PC single-sided? I mean, it's the same. By the way, I see North Star on that list.
Except it has 18 sectors.
Yeah, IBM PC used different number of sectors, didn't they?
Yeah.
Well, well, that's again one of the reasons why I like using command line.
Let's just see what happens. I don't think it's going to be. Whoops. Can't write an 80 track to an 80. No. Golly.
Write it right.
I want this one. Well, it's doing it.
Oh, that's right. IBM's used 9, 5, 12K sectors and not 18, 256K meg sectors.
Hey, it's trying to do track 40 and it's not working. Okay. Save raw flux. Oh, this is I guess this is the Flux Engine software.
Yeah. Try doing an SCP copy with the command line tool to get a version of that.
I'm not familiar with the command line, so if you can drive, I can do it.
No, well, the same thing that you've been doing, just do the GW read cylinders. You know, I'd still do 39. Just do a read to SCP and then just look at it.
All right. We only need up to 34, right?
You could go all the way to 39 if you want.
We'll go to 39. We'll just take a look at it. I'm sorry that Flux Engine software is probably better for the formats that it has. Maybe one of us industrious people should figure out how to add color computer stuff to it to make it a little bit easier to use. But we can actually. So yeah, I'm sorry that was a brief GUI. It's not only command line. You can use Flux Engine to do imaging for the systems it supports.
Yeah, that I just use the greaseweasle tools.
Yeah.
Okay, so yeah, the last 5 tracks definitely is just the white noise.
Well, we're just doing this to take a look. So, whoops. I did not want to move that. Sorry about that.
No, you didn't. Now we need the other tool. There we go. Test 4 at the bottom.
Right. And what did you say about
view? Dummy view if you can, or whatever. I don't remember what track it's on, but I'm pretty much sure that there was a sector. Oh, everything looks fine, but yeah, there was either a bad sector or there was a different numbered sector on one of the tracks.
Look at that weirdness in the inner gap between the track end and begin.
Oh, you mean somewhere like over here?
No, down at the bottom there in the unwritten area. Yes, with the red stripe in it. There, that.
Yeah. Oh,
that's the start of the track. That's normal.
Is it? Okay.
Yep.
How do I change this? Is it this one? No. You're actually seeing. Actually, not this view. I guess that was the right view. You're actually seeing this red mark right here, which is the beginning of the track.
Oh, okay.
See how there's a gap? This is the index pulse. So
right. Okay.
There are little extremely minor timing issues here and there, but these are not a big deal. You thought it was track 9, David?
No, I thought it was like a Sector 9 or something that was bad, but I don't remember what track it was on. But I know my disc that I've got, unfortunately I'm not at home and my discs aren't are stored away. But yeah, I could never do a
Okay.
backup of it.
I don't. I'll have to look. I'll have to look at this disc more to see if I can find what you're talking about. So
I know some of the Sundogs games also for sure had copy protection, but it's just interesting that when you can look at those discs and you know that you can see the variations in with the disc view.
Yep. So, David, at this point, I'm going to set up for my last demonstration. So, I think you had a few things you wanted to show as well. So, this would be a good time. It's about 6:30, right? So, let me set up for the last demo, and you can show something.
Well, most of the stuff that, strangely enough, I set up for, you're also already doing. So
Yeah.
the only thing I've got that's different is I've got different models of the grease weasel. So, you know, I have the F7, which is in the form factor of the CryoFlux. I've got the V4, which the V4 supports up to 3 of the Shugart drives on a cable or 2 PC style configured drives with the twist in the cable.
Yeah, we talked about that earlier.
So, but that's really the only things I've got. The only difference is that the screen I was showing is you're on a Mac, and my view was from my Raspberry Pi, so you don't even have to have a full-blown desktop PC set up to clone or image floppy disks, as long as you got a grease weasel.
It's absolutely possible to run it on the Raspberry Pi. So, yep. All right. Well, so here's my adapter redo for power.
And Mark,
And
the big view is there you go.
And then which way does this go in? This particular drive does not have a
Key
thing.
should go to the bottom, I think.
Look for an arrow on one of the sides. The arrow would be pin 1. Sadly, I can't see it from here. You'll have to look for a 1 or an arrow.
Yeah, or that little cutout in the frame should be the keyway.
But there's two cutouts.
Well, you got to hold still.
See, there's 2 cutouts.
Your light's
There's one on the
blocking our
top and
view.
one on the bottom.
Ooh.
See that?
Yeah.
Okay. I'm just gonna plug it in and see.
Multimeter handy?
What's that?
You have a multimeter handy?
I can get it in a second, but I'm just gonna plug it in and see what happens because.
Yeah, if you power the floppy drive and you've got it backwards, it'll immediately turn on.
The light's lighting up. That's backwards.
Yep.
I plugged it in. The light's lighting up. It's connected backwards.
Yep.
Let's turn it around.
That's one nice thing about the floppy cables, since they're
I want to mark that for future use.
It's what, open collector? So normally open collector stuff, it's usually not.
And plus, every even row is ground anyway. So
how's that, Mark? Arrow.
Yes, excellent. Little arrow.
Yeah, it's pin 1 through
Sharpie's your friend.
39. The odd, or 33. The odd ones are ground. Except if you're dealing with the Macintosh floppy drives, pin 1 is actually a separate pin, and that controls the eject motor.
Oh, don't forget the external Tandy 1000 floppies.
Yeah, I'm not experienced with those.
Well, they brought the power through the data cable too.
Yeah, yeah, I didn't realize I had a couple of the Macintosh floppy drives until I plugged them in, and the drive auto-ejected the floppy drive, the floppy disk.
I see
Yeah,
some real
barf.
IBM discs.
Yeah.
Is that just a display writer?
Oh, you want to actually look at these? So,
I just hope you're not killing OS2 discs. I'd be crushed.
oh man, this one has utiliterm. This one has OSterm. This one has RickyTerm. Somebody likes. So we have 2 copies of RickyTerm.
Oh yeah, it's on
Somebody likes
Microsoft disk.
terminal programs. Here's MikeyTerm. 2 copies of MikeyTerm. So yeah, I had multiple copies of OS2, and what this demo is, if you look here, it says high density HD. These are all HD floppies.
And all
You're
the
not
covers.
supposed to use these for. So if you're using a 3.5-inch drive for a Coco, you should not be using high density media. I know that people online say, hey, it works. But there's actually a difference in the magnetic properties of the disk in between HD and this disc is not HD. So this is taped over. But I have one that's not taped over. I don't know if I do.
Yeah, you know what's funny, Mikey, is that when you started saying that, I was going to cut in and say, no, don't use high density with the high density notch taped over. It's not reliable.
I have one. I found one. Okay. So this is a high density disk, and this is a double density disk, and we can literally look at them. So this one has the double density disk. Oh boy, this is a lot of trouble, isn't it?
It has one hole.
It has one hole. See, there's one hole here. There's no hole here, and the high density disk has an extra hole on this side. And
have you ever seen any IBM 2.88 floppies?
No.
I have. The hole on the right side, that single one, is actually moved closer to the shutter.
So you're saying the hole is moved
yes, one hole is closer
way,
to the shutter.
This
exactly.
Way.
Yeah.
Huh, interesting.
And then that's not even to be confused with the 2.44 5 1/4, the ED.
All right. Let's get this demo done, and then we can talk about whatever. What do you guys think?
About the 200 different formats of disk.
Yeah. So what I did was about 10 years ago, I think, I didn't have let me just get it. I got a whole tray of double density disks. This whole tray is all double density disks. I have some brand new ones too. I got this at let me see if I can do this without spilling the contents. Weird Stuff Warehouse, which no longer exists.
Oh man.
I didn't pay 50 cents for the discs. I think I paid more. I paid 50 cents for the tray. So I have more than just this, but these are the ones that I have Robot Odyssey, Code Accelerator. Here's another utilitarian, warcopy. So I've been using these discs more recently with Coco stuff in the last 5 years or so that I've been playing with them. But before that, I didn't have those discs. I literally took these OS2 discs, which were not useful to me, taped over a hole. Remember, it's supposed to have a hole here. You can see that it's supposed to have this hole, but it's been taped over. And I wrote Coco stuff to them. So this demo is I'm going to read these discs in using this drive, and then we're going to look in the software to see if it's actually reliable after who knows how many years. So I'm going to open this this cleaning disk here, and I'm going to run it through.
This is a standard density 3.5, right? It's not a high density. The drive.
This is a high density. So for 3.5, you can use a high density drive for everything.
Right.
You don't need a special drive. This drive here is just a Chinon FC. You know, this is just something I took out of a PC. It works just fine.
So on the 3.5 format, were they all 80 track? And they were just a
Yes.
difference in the density?
Yes.
Number of sectors per track, yeah.
And the the density, number of sectors, I think the speed is the same, right? I believe the speed is the same.
Yes, the 3.5-inch floppy drives for the CoCo and PCs are 300 RPM.
Between the 1.4 and the 720s.
And the 288s, they're all 300 RPM. It's the bit rate that between the drive and the controller that changes.
Right. Okay.
I believe it's I don't remember the phrase, but the clock is basically 250 kilobits per second. High density is 500, and ED is 1000.
There you go. I had to do a reset on the greaseweasle again. There's some problems with something in the software here. All right, that should be clean enough for this. Just don't want to mess it up. Let me put this back in the box so it stays clean. Then we can go. All right. So for the very first one, now I actually can't. If you want to see what the OS2 stuff on this disk is, I actually can't because you have two different densities. If I tape over the hole, it's going to be stuck in double density. If I take it off, it's going to be trying to read high density. So I can either do one or the other, right? Do you understand what I mean? I don't think I explained that very well.
Yes, it's not like where it's what is it, FM versus MFM, where the encoding's different. It's the actual speed is different. So
well, that switch signal goes back to the controller, and so it's telling the controller what speed to use.
On the 3.5, yes. The 5.25, actually, the controller tells the 5.25 which mode to be in.
Right.
Which is why some people will cut that trace on a 5.25, and they'll put a switch on the front of the 5.25 so they can manually force the drive to be high density or double.
To adjust the speed.
Yep.
And there's some drives like the little the high density drive I have, you can put a jumper on it to lock it at 300.
Yes.
And then it becomes
the one
a
high
nice
density drive I have, I've got it. The 300 RPM is only used when it's in double density mode.
Right.
I've been wanting to build a imaging station where I have all the different kinds of 5.25 on one thing, and one 3.5 to cover the 3.5-inch discs.
Well, that's how I use the 1.2 meg 5-inch disc on the CoCo. Is I strap it to 300 RPM, so it becomes a 720.
Yeah, which the early Tandy 1000s came with, I believe, a QD drive, which is basically a 80-track double density drive.
The 2000 had that.
No,
Tandy 2000 had the 720. It was
Yeah,
basically
had the
80
720
track.
drive.
Yep, dual side. I had a friend that had a Tandy 2000.
Yeah,
no,
I've
that's
got
interesting
one
because
of
the
those
high
drives.
school I went to, they got in the one lab, they got some Tandy 1000s and they had the 720K 5 1/4.
Maybe I thought they all had 360s, but the 2000 did have the 720s.
Not unless it was a special order.
It's just what they had. They were half height. They were. Oh, I've got one in here. It was a different manufacturer.
Well, I know I had one of those drives because I had acquired one and I was using it on the Coco. I loved having 80 track 5 1/4 on the Coco.
Yeah, I used it on the Coco too. The drive has since failed, but it's Mitsubishi. One of these guys,
Mitsubishi.
but with that push in to release it.
Oh, that's interesting.
What disc is this? OSterm.
It's an M4853.
I forgot to bring my box of drives upstairs. I retrieved the box of drives that I had from my parents' house, and but I forgot to bring it up here. I found 2 bonus discs. Here's an OS9 boot disk, this is a much, so these IBM discs, these are actually very high quality media. I don't know who made them. Where does it say they were made? One moment. I can read this. It says assembled in USA, huh? These ones are super cheap. It says made in the USA, but if you could hold this black disc next to this one, this thing is so thin and floppy. This is heavy. Super heavy.
Made in USA, right?
Anyway, yeah. So we'll do these 2 bonus discs too, because I don't know. These are much newer media, and so probably they're going to be less reliable. I have 3 more discs to go. While that's running, let me put these flex disks away back in their box. Oh, there's an additional intro disk I didn't get to. That's okay. I don't think it's necessary. All right, now let's do the 2 bonus disks. This one says OS9 boot disk. Let's
I'm
see what
going
that one
to
looks like.
assume that you're wanting to change that to 82 tracks and double-sided, right?
It says 08. I don't know what that means.
Yeah, I'd assume that you would have used the full capacity of that disk with OS9.
Probably. Not the boot disk though.
Oh, my boot disk, I had maxed out the capacity.
All right. Let's see if it's using all 80 tracks or not. And double-sided. So just say see what we got here. I think there's data on second side.
Indeed. Now, there's another trick that you can do. Since usually the 3 rotations you don't need, since these are not GR or what is it, GCR or GRC, whatever the Commodore and Apple formats are, you can set the revs to 1, which would speed up reading.
Yeah. That's okay. If there's anything bad, it'll
Trust me,
get it.
with Curtis's floppy, I had to set it to 5.
Wow. All right. While that's going, we can look at something else. That's just finishing up. So let's take a look at OSterm. See what that looks like. I see some red in between the sectors, more than I would say is usual, but it looks okay. What do you think?
Well, usually that red looks like it's in what would be called the sector header, but as long as the sector data area, the CRC is reporting that it's good and green, then I wouldn't worry about it, because that's the part that you care about, is the data. So,
and here we can actually see that if I zoom in a lot. In fact, somebody asked about this. You can zoom in and look at the actual data. Anyway. Okay, this looks okay. That was OSterm. How did Ricky term do? Looks okay. So these are actually good discs. It looks like, even though we're advising against doing this. OSterm, Mikey term. Looks okay too. Yeah. There's no issue. There's no real big issue with this. Well, so far it's doing okay. So let's take a look at those cheap discs. Let's look at the boot disk. That looks okay too. What do we want? Track. What track is that? Is the boot thing on? Hello? What's 9 boot disk?
Track 17 was where when you hit DOS, that's what it read. Is that what you're asking?
No, the actual data is on track. Is this sector 1? Why does it not say OS? Anyway, this disk seems okay. Sorry, I'm off the screen. I apologize for that. The OS9 boot disk seems fine. How about the Nitrous 9 disk? Where is it? Nitrous 9. What do you think? Looks like an 80 track double-sided disc to me. Surprisingly, I'm actually surprised. I got good reads out of all of these discs. However, just because it worked doesn't mean it's reliable. I still would absolutely not advise you to do what I just demoed. I would advise against people taking a high density disk and taping a piece of piece of tape or sticker over the hole. I would not do that, no matter what people on the interwebs tell you. It may or may not work. In my case, all of my discs read, but
I mean, you might get away with it for a while, but when you most need it, that's when it's going to let you down.
I think these discs are 20 years. 2003, 2005, somewhere around there. Maybe even longer than that. These discs are probably more like 10. Whoops, not that one. It's in the drive. These two. There you go. So, well, that was my entire demo of everything that I wanted to show. So, looks like it actually took 2 hours.
Has it been 2 hours?
Yeah, it's 6:51. I'm ready for dinner.
You're ready for dinner.
Yeah.
So, well, geez. So what is there any questions from the chat that might need to be answered, or so I
I
don't
had
have
some things pop up, but I think pretty much I asked them all. So
yeah, because most of the stuff that you covered, Mikey, I would have covered. The only thing I do is I'll have a generic disk image that I'll write to a floppy, and then I'll read back to a test file to check to see if the disk is bad, so that way if it reads and it's red in any areas or stuff like that, then yeah, I know not to use that disk and throw it away.
Yeah.
There's other features of the greaseweasle software which I guess I could bring up, which is good for being used with the, let me see if I can use the right trackball here to get to the right machine. And I'll close this. So one of the features of the greaseweasle software is that it can write to just the raw sector dump images as well. Let me, and that's under the format section, I believe. Format.
Something else I can show. Let me dig around a little bit.
Yeah, I'm trying to find the section on the formats, because that's really useful if you just want the standard Coco floppy disk image for use with the SDC. Yeah, I didn't notice the clean option was there. That must have been recently added.
I wonder what this is. Let me see what this disk is. I don't remember. Oh man, you guys were asking about the floppy disk. Unopened. $8.
Yeah, I got a box of Fuji
still
film,
sealed.
double-sided density.
This one I opened. I opened this one. It was $1.
That better? Oh, yep. Actually, what am I even okay?
Oh, hey, look, Fuji and Fuji.
Yep, that's the same ones that Kevin's showing for me on his screen over there.
And then this is cool too. See this box here? Dyson.
Nice.
Our local color computer club met in the auditorium at Dyson Corporation, not Dyson, Dyson, Dysan. And I have this one. This is the last thing I bought from a surplus store that closed, called Halted Specialties.
Yep.
This is a box of Dyson 5 1/4 inch discs, and this is one of the last things I bought from them. They had more of these. I only bought one. I should have bought all.
I bought them all.
Okay. And then there's this. You want a floppy? Here's a floppy.
8-inch.
Real
Yeah,
floppy.
that's a good 8-incher there, man.
It's even a Shugart branded disc. Can you believe that? SA100 disc. Can't believe it's a Shugart. Oh, here's the actual jacket for it. Actual Shugart.
And that's still a
disc.
soft sectored?
No, those are usually hard sectors. I think.
Yeah, I believe so.
Look for extra
There's
holes.
only, I think there's only
I
one
thought
hole.
the original Shugart ones were hard.
This guy is not really turning that well. I'm not going to mess with it. I don't think I have any drive for this. Okay. I found what I think is a DOS diskette, and I'm going to try to use Flux Engine again. Just because somebody asked. Need this one. So let's try Flux Engine again. And this time we're gonna say it's a 720K 3.5. Let's see what that does. Whoops. So one of the things about the Flux Engine is it actually shows you like the this is not the waveform, this is the histogram of the actual magnetic flux that's coming back. You can see that it's in one of 3 different states, which is pretty interesting.
Indeed.
I'm sorry I couldn't do Coco things with the software. But we'll get to see what's on this disk, since I think it's a DOS disk. Oh, it has bad sector. You can see that. It says red. Couple bad sectors. Yeah. That's fine. Yeah. So this is a DOS disk. The label said it had PCC, which is I forget exactly what this thing is. It's some kind of simple C compiler that's on this particular disk. So there's a couple of bad sectors. I don't know if I'd be able to read this completely. So this is kind of an example of what you can do with this software. Explore disk. Oh yeah, you can. It'll actually show you the data. It's not doing it. All right, I don't know why it's not working. I'm not that familiar with this particular software. It seems to be stuck. So that's enough of that. But Flux Engine software does work with the greaseweasle if you want something that has some graphical. So, all right, I'm not going to show anything else. So I said I'm getting hungry. So,
well, I'm just if you look on my screen, I've got the command line written for doing a disk read, but using what most people, if they're on the PC, know as IMGs, which is basically the raw sector dump, which most people know is used on the PC. but it's also still very usable on the Coco. Well, the software for the greaseweasle software supports it, and there's already a predefined Coco formats available that you can choose from. And there's one here called coco.os9.80ds. So I can start a disk read, and it will create that disk image there that I've labeled for the .img. And right now it says it's an IBM MFM, 18 sectors, and it's reading from the raw flux, and then it will create the IMG disk image, which then can be directly used in the Coco SDC as the .dsk without any issues. Which comes in handy if you want to use a greaseweasle or a greaseweasle just to convert your floppies to be used on your SDC.
So you said it's going to read in the flux image first, and then it's going to do the conversion.
It's already doing it as it's reading.
Okay.
See, that's
Okay.
why it, because
And it'll show the map at the end, right?
I believe so. I've had it where it found bad sectors, and then it would give an error after each one. It would say it read this number of sectors out of, like where it says 18 to 18 right now. It would be, if it had a bad sector, then it would be 17 to 18.
Yeah.
But if you read a disk image with SCP and open it in the HXC floppy emulator tools, look at it, and all the sectors are green, then you can turn around and do it this way, and reread the disk image to make, see, like right there, it said,
make your window bigger.
Yeah, I got to do that. Hold on. Like I said, this thing was just set up today. So
there we go. Yeah. So this is what I was talking about. This is the sector map. So you have head 0. Across the top, you have the cylinders. So you have 0 starting on the left all the way up to 79. So that's the columns. And each row is one head and one sector.
Yep.
So.
And this is how I do most of my stuff. Now, of course, there are quite a few of my double density, and yes, I will say this, I have some high density 3.5-inch floppies for my Coco as well that are definitely way out of range of normal Coco specifications.
Yeah.
But this software is great for reading that. And I strongly recommend anybody that's looking to archive their floppies for any of their color computers or PC floppy disks. The greaseweasle's the cheapest option, obviously.
Yep.
CryoFlux is definitely expensive. At least to me, it's expensive. For those that are Apple users, there's the applesauce, which that's also not cheap. And then, of course, you got the SuperCard Pro, which is, I think when it was available, it was roughly $100, but it's currently not available due to the same chip shortages for certain types of chips.
Yeah.
But otherwise, the greaseweasle's still a great option. And if you want to try building your own, the information is on the greaseweasle's GitHub page under the wiki about the F1. So you can build your own, which of course that version only supports one drive connected to it. And if you want a pre-built version, the wiki has links to places that you can buy the F7, the version 4, and I think the version 4.1, which is well worth it if you still deal with floppy disks.
I'm very happy, David, that you and I were able to trade, and you were able to get me a greaseweasle, because obviously this past year I've done some, some of this Flex stuff. I've done some cool stuff with it. So thank you.
It's no problem. For me, the greaseweasle has been a very useful tool for recovering floppies, and of course, one person can attest to that is Curtis. So it's a great tool for recovering old stuff, especially when certain hardware isn't working anymore. Right?
Yep. So unfortunately, we missed one presenter today who was not able to make it. So we might have another floppy talk. And
I already figured we would, but anyway.
I think that it would probably be a good idea for us, David, next time we do a floppy talk, to step back a little bit and maybe talk about, instead of flux and images, how would you use floppy drives on a CoCo today if you wanted. Like you can use a 3.5 drive, just regular PC 3.5 drive, just fine on the CoCo, as long as you have right media, that kind of stuff. little bit more, user friendly discussion. What do you think? Because we're really in the weeds. We're really down in the geek weeds today.
Maybe a little bit on D mode when you're setting up your different drive types.
Yeah.
For OS 9.
Yeah. Just an idea for something we might want to do next time we do a floppy talk. We can kick the idea around.
Yeah.
Don't be embarrassed. Go deep.
Oh, there's definitely options. And then of course, if we have people that are used to different disk basic ROMs for different disk basics that were available, that's another one.
Well, that rabbit hole can go so deep we'll be in China.
That's why I'm foreseeing this particular segment having a few episodes just for this one alone. So the greaseweasle's one version. Next we'll have
SCP.
Yeah, once we can get Paul.
I think somebody has applesauce. I don't have one. I'd like
Tim
to get one.
Lindner.
I don't have one. Tim Lindner. Yes, I thought. And Tim Lindner has one. So we'll get him on.
Yeah, he was showing it to me at CoCoFest, and that's a great looking tool for those that have Apple machines. Definitely not in my budget because I don't want to spend a three grand Apple to turn around and get an applesauce. Or
I'll set you up with an Apple. I got a few spares.
Well, technically, I've gotten a what is it? The Mac Mini, but yeah, but it's an older one. It's not an M series.
I'm just pulling up that link to that manual that has the deep dive. Well, I guess this link will work. I'm gonna put that in the chat.
Yep, go ahead.
It's the Shugart SA 800 Theory of Operations, and it talks all about how the flux works and FM and MFM and all that stuff is in this manual. It goes really, really, really deep about how everything works.
Oh yeah, and then I guess I should put my camera back on me instead of that pie.
Guess I can put it on screen for a second too.
Yeah, the other thing, Mark will probably have to
Oops.
put the link up on the YouTube to go out to propagate to the other streams.
Yeah, I mean, we're talking about FM and M2 FM, and they even have the more basic magnetic part. This is just crazy deep.
Oh, and then you also have the early Macintosh floppy disks that each track was spinning at a different speed.
And then you go over where the flux capacitor goes.
Yeah.
Actually, the Apple II's drive did that too. That's how they got
Anyway.
800K on them instead of 720.
Oh, I didn't realize the Apple II did that too.
Mhm.
Wasn't there a commercial PC that actually used 800K as their standard?
Maybe.
I was thinking like either the Amiga or something where it wasn't. It didn't advertise it as a 720. They advertised it as like an 800.
Yeah, that would
Unless
be
they were
the
talking
Amiga
about
because
unformatted capacity.
yeah, because Kevin just mentioned that it's the Amiga because theirs are
Okay.
880.
Yeah.
because with the greaseweasle, I did a read of one of his floppy disks, and you can read directly to the ADF format, and it will. Yeah, each track has a different amount of data stored on it.
Eey.
Well, it's because the innermost track has the least amount of space. So, and the outside track has the most surface to use.
Even the Commodore 5 1/4 drives, the 1541s and the 1571s, 1581s, they had variable space also.
Isn't the right precompensation supposed to cover that or compensate for that?
But that's again why. Well, that's to keep it where for the PCs to keep the data flowing at the correct rate.
Yeah, because once you get
But-
past track 17, right precomp comes on to change accommodate for the shorter track.
But yeah, but for those other machines, they just took advantage of that extra space because that's why you have 880.
Getting rid of some of
Apple
that
had their
gap between
800K discs.
Okay.
There's a lot of cool stuff that different machines did to get extra space.
Ring out every last little byte.
Alrighty, guys. I think it's almost dinner time here. So
Now, well, I don't have anything else because pretty much Mikey and I both have pretty much the same equipment, and he covered pretty much everything.
yep.
He
That's all right.
showed 3.5.
We were here for moral support.
Hey,
Okay, I guess we're gonna.
We
call this
finally
a
did
wrap.
floppy talk. Yay! Floppy
Yes.
talk is done.
Floppy Talk Part 1.
oh yes. Again, we've got the parts from OS9, which, well, I think that would be pretty short, unless of course you start getting into the demode stuff for setting up the drives. But
That'd be a good thing to cover too.
Yeah, because that's how you tell OS9 the physical geometry of your drive.
for
I
format,
guess
usually
yeah,
after
OS9 doesn't
that,
have partition tables, so
yeah, usually the first sector, which is LSN0, has the information about the geometry of the disk. So after that, OS9 can use it. But
Oh boy.
when you first
Yeah,
format the
but
disk,
RBF. SCF.
It's easier if for a higher drive to read a lesser disk, it works pretty well. But for a lower drive to read a higher density disk, it can have some issues.
that's why when it reads sector 0 on side 0, if it's bigger, OS9 should give an error going, nope, not going to do it.
Yeah, it says like wrong type or something like that.
Yep.
What, 247 or something like that. Anyway.
But I guess maybe we should put a fork in it until next time.
Yeah.
till next time. At the moment, I don't have any more CoCoTECHs like this scheduled, but we'll get some back on the board after January 1st. So
That's no problem.
say good night, everybody.
Bye.
Night, everyone.
Night.
Bye.